Hello and welcome everyone. I'm here to talk about microfrontends from development to deployment. Let's quickly take a look at the agenda and what I'll be talking about throughout the session. I'll be talking about the inspiration for microfrontends. Should you use microfrontends? We'll move on to see how the team dynamics change when we have micro front-end implemented teams. Different ways to implement micro front-end. We'll take a look at a case study. Bank as a configuration. We'll dive a little deeper into the design and architecture. What are the problems that we faced? What solutions we've come up with for gatekeeping, our CI/CD, our releases, and how we plan to scale it from here on as well. To start off with, I wanted to just take a look at Martin Fowler's example of or explanation of what a micro actually means. So he says it's an approach to developing a single application as a suite of small services, each running in its own process and communicating with lightweight mechanisms. The idea over here is that you have a monolith. Now, if we take a step back and take a look at why microservices were implemented in the first place, you start seeing why one pattern was preferred over the other, and then you start realizing the benefits of why this was broken down in the first place. To understand this problem statement itself of why do we even need microservices or micro frontends in the industry today, let's take a look at what does law of diminishing returns teaches us. What law of diminishing returns says is that there will be a decrease in your marginal output of a production process when one factor of the entire unit is changing, where all other factors are remaining constant. Then your entire output would not be as efficient as a small team. Now, if just taking a look at the graph, if you see when we have smaller teams, when we have small features coming in, the development team has complete context of what they're building around. The integration with business and capability is really good. The team is most productive at this time, right? But then when the project starts scaling up a little bit, you start seeing diminishing returns and your time to market is not as fast because you've increased the number of developers on the team, but your application infrastructure itself does not support that kind of a scale. If we start scaling up even more, we start seeing negative returns with a lot of defect injection into your production code base and things like that. So the lesson that we learned from this graph is that we want to stay as close as possible to the left side of the graph where the team is the most productive. To see how the teams have evolved over the years, this is how it was back in the day when your front end, your back end, your entire team for this application was working very closely together. Your deployment processes were closely knit. You couldn't carry forward your front end changes without your back end changes and things like that. Then we started seeing this problem. We wanted to have a separation of concerns. We moved to have dedicated front-end teams when our clients as well started becoming thicker. Our browsers were stronger. We wanted more focus on front-end. This separation was logical. Then the back-end team realizes that, again, having a monolith as the entire application is kind of blocking us to go live, or our features time to market is very long. So they broke down into their individual capabilities and then started building microservices as backend. Now with the front end world, again, this is where micro front end start coming in. And then we have vertically sliced capabilities now where individual feature team works with the individual backend capability team very closely. The entire team is context rich on what they're working rather than having context of the entire application. Developers become much more efficient when we have such vertically sliced teams. So front-end, micro frontends itself is not just a fancy JavaScript segregation of how you're achieving micro frontends. It's your team dynamics and how your entire team starts behaving differently towards the entire application. Now, is micro frontends a one-stop solution? Do we have a kind of a set framework that we'll be following? Possibly not. So the micro frontends implementation can be very custom on basis of your own needs. So these are some questions that you'll have to answer before you make a decision as to you're going to go forward with a particular framework? Do you have different frameworks? Do you have different versions of frameworks to be supported? Or how does your entire team behave to different frameworks, and how your architecture comes up? How do you want your deployment and your pipeline structures to be, your CI/CD? Do you have shared modules? And how are you going to propagate this to production once you have common changes coming to your shared modules? How are you going to dynamically load these individual micro front ends? Are you going to prefetch them? How does your performance scale that way? Do you want, is server side rendering a very important aspect of your entire application? So when you have answers to all these questions, you get a much more clear idea to start implementing micro front ends for your own application. But one very important thing to be considered, irrespective of all the answers that we saw on the previous slide, is your release cycle itself. With micro frontends, the crux of implementing micro frontends would be that you need to have your independent deployment cycles for any of your individual packages. As you see on the screen, you would want to have multiple micro frontends, and they should be able to build and test themselves in isolation, not as a monolith with the other micro frontends, and they get stitched or composed at a later point in time when it goes in production. So getting this release cycle is really important for your micro frontend implementation. So just at a very high level, just talking about how different ways you could implement micro frontends today, I would divide them into, at a granular level, you can have multiple divisions. At a Uber level, you will see that you will have client-side composition, edge-side composition, and server-side composition. In client-side composition, what we're saying is individual micro frontends, as you see on the origin part of it, you have deployed all of your individual micro frontends to production independently. But then what your client is doing is the client is responsible to compose all of these individual micro frontends, because one big difference between microservices and micro frontends is that at the end of the day, you would want your micro frontend to look like a single application to the end user rather than going to multiple applications. So we need a composer or a stitching layer. So you could have that on the client. We could have edge-side composition. What edge-side composition does is that CDNs like Akamai now support server-side includes, where you could just mention fragments of micro frontends as a template, and then what Akamai does is, or any CDN for that matter, will stitch all of these fragments, and then the client does not worry about composing. The entire application is given to the client. Custom implementation could also have server-side composition, where the first two could be serverless architectures, but the third one, the server-side composition, would need to have a dedicated server running, which will stitch all of these individual micro frontends on runtime and return it back to you. So this was a highlight of micro frontends that I wanted to set up before moving to a case study. We'll take a look at problem statement and how we went ahead and then solutionized it. The requirement was to build a multi-brand application. It's a banking application. So we initially segregated and we separated 50, 60 of these features and put them in different buckets. You could say if it's a bank, you could have transactions as a micro front end, making payments is a micro front end, just viewing or making changes to the customer's account information could be a micro front end. We wanted to have federated teams who work closely with the capability teams. They all had individual release cycles. We wanted not one feature to be bound to the other feature, so that their time to market depends on how business comes up with features for a particular business unit. We wanted to have a common stack across to have consistency. We'll take a look at what are the benefits of it at the end. And we wanted to have automated CI/CD deployments of these individual micro frontends as well. This is the stack that we've used to implement this case study. We're using React as a UI library, Webpack as a module bundler. We've extended Material UI to build our design system. We're using Lerna for tagging and publishing of these individual micro frontends, using Yarn workspaces to symlink all these individual micro frontends in the developer environment, which we'll talk about it in a bit. What does our very high level design looks like what you see on the screen now, where we have a single micro applications, like you see, add a pay, make a payment, authentication. All these are individual micro frontends, but then we wanted client-side rendering. So we have an assembler, which is an independent entity of it by itself, which is a kind of a smart layer, has a custom router, and what it's responsible is to fetch these individual micro applications and make the user feel like it's a single flow throughout. So the assembler is supposed to be a smart layer, and the micro application itself don't understand how the entire application works, but they just need to have context of how this individual micro application and what feature it's showcasing to the customer. Just diving a little bit deeper, what we saw, the assembler or the composer layer, it fetches these individual micro apps, and these micro apps in turn register back to this assembler or the composer. And they have a kind of a strict contract between them as to how they act as a parent-child relationship. So the parent is providing any data that or configurations that this micro application needs to behave differently, and these micro apps just come mount onto the screen. They display their feature, and then if there's a switch in the micro app again talks to the custom router, and the custom router says, this is the new micro application that will be fetching. At the same time, these individual micro apps have access to the store. To see that, we'll take a look at it a little later, how we're using our state management library. So one thing that I would highly recommend, this is true in possibly any size, any kind of application, that you have all your design decisions sorted right at the beginning before implementation. You do your R&D, you know what your custom business requirements, and get your core architecture sort right at the beginning. That's true for all applications, but I would strongly recommend, especially with micro frontends, because as they scale, they are in their individual entities. We would want to have all of these core design decisions right at the beginning, so that it's a smooth process later on. And making very huge design decisions after you've implemented it could be a little chaotic. So let's just walk through some of the design decisions that we had considered, and what are the problems that we faced, and why did we even make these choices. So we wanted to have one instance of the core UI library that we're using React. We wanted to just have one instance rather than individual micro apps coming up with their own frameworks and having multiple instances of React. The reason being that we're using React's context API, and if there is one instance of React, all these individual contexts are in sync. So we could use that for state management. At the same time, this reduces our app footprint as well, because we have one instance of React loading right at the beginning, and these individual micro apps are very lightweight, just bring in their feature JavaScript, and with React's single context, we're using Material UI's theme provider. So like I said, the assembler is a smart layer, and the assembler sets a theme for the entire application, and the micro apps just respond back to that theme, rather than having instances of multiple themes within micro app. You can't achieve this if you have bundled React within the micro app, because it would have its context in its own lexical scope. We would want to have one context right at the beginning, and these micro apps respecting that same context throughout the lifecycle of that micro application. So in terms of state management itself, we experimented with some popular state management libraries, but then we realized very soon that once we have this micro front end itself, the application is quite small in size, and you don't have to rely on any third-party state management. You could just rely on React's context API. So we just have context providers throughout. And like you see on the screen over here, you have, say, a particular journey, and now via configuration, we give access to this journey to specific stores. we have these stores built as well, logically separated with how different parts of the application, say accounts, products, customer information, and authentication stores and things like these are logically separated. Now, possibly not all journeys require access to all of these individual stores. So via configuration, we drive that and say a make payments journey has access only to the payment store and possibly the customer store as well. So this was more than enough for us to handle our state throughout the application. So we're using Webpack very heavily to build our micro frontends. The reason for that was, if you guys are aware of it, Webpack 5, which is in alpha stage right now, has module federations with very good support for micro frontend kind of an architecture. So what module federation says is that you build your individual micro apps, but then if you have context of how these link with each other right at the beginning during build time, and you have those dependency definitions with Webpack, then when you go to your higher environments, the assembler or one of your core layers has context of how to manage these dependencies of individual micro frontends. What we saw earlier was we have a custom controller right now, a custom router which does all of this. But in the future, when Webpack 5 is out, we can make an easy switch and let Webpack do all of that heavy lifting for us in terms of our micro front-end dependency management, rather than we taking care of all this custom routing logic. One more design decision that we took right at the beginning was that we will have error boundaries at a micro application level. So this gives us, this limits the blast radius when things go wrong with one micro application, rather than just crashing the entire application. So if this also gives us the confidence for individual micro application teams to say, even if we go to production with whatever behavior that we have, we're not going to create problems for any other micro applications. So having error boundary right at the micro application level gives us a lot of confidence. So we were talking about one single application so far and how we built it, but then the case study also had a use case for multiple brands. You wanted multiple banks up and running with the same code base, same features, not a lot of features change between brands. So for that realization, what we had was these individual micro applications that you see are brand agnostic. They do not have any brand kind of a logic. They just are very feature rich, and the entire feature is baked into the micro application. Now coming to the assembler had the brand, basically the theme, the breakpoints, analytics configurations, application configurations, API connections, and all of that with the assembler. We just took it a step ahead, and what we did was this entire assembler, we made it as lean as possible with brand agnostic kind of controls. And then we took all this brand configurations right to a separate package, which is an individual bank. So now that we have two banks, what you see on the right side, these are just not themes. This is an entire banking application. So you don't even have to deploy all of these individual micro frontends or the assembler again. So if I want a new bank to be set up, what I do is I just get a configuration for that bank with a particular contract for which binds with the assembler. And then if I just take that bank to production, point some domain to that bank, you have an entire banking application up and running in no time. So this architecture is something that we've taken to production and is being used by our internal users and soon to go live to end customers as well. Keeping all of that in mind, when we had assemblers, we had brands, we had micro applications, even though they are separated out into different packages and we have it in a mono repository, we wanted our pipeline to be smart enough to pick up the chain set and build only the artifacts that have changed from the previous release to the current release. We're using trunk-based development, so every time you're releasing, you're actually taking it to production. So we wanted to have that confidence that we are taking new artifacts to production for only the ones that have changed. So we're using Lerna as well to find the chain set of all the dependencies, and then we just build them. We publish to our registry, and then we deploy it to our higher environments. And we rely on Lerna's publishing and tagging mechanism as well for our incremental releases, where we have incremental tags, and then this gives us a clarity of what version is currently being propagated across environments. So once we did that, we thought it was warm beaches and pina coladas. We're done with a lot of heavy lifting. We thought it's a stable environment for a large scale application. It was all good. But then there were some parts of the application which led us to some problems, which we'll take a look at. So the developer environment itself, now we were talking about micro frontends where they are built in isolation, and they behave as single application onto the client's browser, but if they're built as individual building blocks of the application, then during development time, I'll have to build that time and again so that I can see my latest code changes. So building that every time was cumbersome and time taking. So on development environment, we chose not to have a micro front-end kind of an architecture running on the developer's environment. We wanted to symlink all of these together. So for that, we're using Yarn workspaces and linked all of them together so that the developer does not have to rebuild individual packages to test it again and again. Now, this led us to another problem where in a developer's environment, it's all symlinked, it's working fine. And on your CD, it's working differently. This catered to that old school problem that we've had, that it works on my machine, but not on the pipeline and things like that. So what we did was we created a local Docker kind of a workspace, which mimics exactly what our higher environments look like. And then when the developer has finished developing this symlinked packages all together, they can individually run their micro front end kind of a behavior on their local using this Docker. And then when the developer has confidence is when this code is propagated to higher environments. This was a problem that we solved earlier. And then we wanted to have a monorepository rather than breaking this entire application into multiple chunks. And with monorepositories came its own problems and its pros and cons. So when you have a monorepository and a number of micro frontends all residing in the same repository, gatekeeping becomes a huge problem, right? So where I'm responsible for some of the features, but then not all of them. So how do we take care of what packages are assigned to which gatekeepers? We use GitHub's code owners very strongly, and then approvals from the gatekeeper is definitely required for the feature that that gatekeeper is owning and things like that. So dependency management becomes really easy because you don't have to clone a number of repositories with individual micro frontends. You have all of that set up in one place, and then the dependencies are linked to each other. Collaboration becomes really easy when you're building features, and teams can learn and teach from each other. Take a look at how other teams are implementing a similar feature and reuse some logic and things like that. Collaboration becomes easier with monorepositories. Refactoring at the common layer, some shared modules that we were talking about, becomes much easier when you have a monorepository. The setup time as well. When you have, like in microservices world, you have individual microservices as a repository, and then getting all of them up and running on your local machine takes a while. But with monorepositories, it's just like having a normal application. As I spoke about it earlier, we're using Lerna for our chain set recognition. We're using it for our version management, for tagging. We use parallel execution across our builds to trigger test and build of multiple packages together. So what are the key takeaways of this session? Now that we've learned a lot about micro frontends, how it works very well with large scale applications, these are some questions that whose answers will definitely help you in making a choice of going ahead with micro frontends or not. Is your service representing different business units, different features, and are they logically separated? Do they have different deployment times? in terms of your time to market. One is feature rich, the other one is just another feature. They have different time to markets. How does one feature scale faster than the other, and how you don't want to be bound by the other part? Have you seen applications where it grows so much in size and complexity that you're technically handicapped to make changes, that your code is so fragile that you're not able to make changes upfront? And micro frontends, you would have smaller building blocks and you can make changes much more frequently and easier. And in terms of frameworks as well, what frameworks do you want to support, and everything that we saw earlier. So these are some questions that we definitely need to answer before going ahead with implementing micro frontends. Also, there is a session from Bashan, my colleague, after a couple of sessions, who will be talking about how you break down an existing single page application into a micro frontends. Check that out as well. That should be really interesting. That was my time, guys. If you have any questions, please feel free.